Welcome to the lesson on constructions. At the end of this lesson, you will be able to divide a line segment in any given ratio. You will also be able to construct a triangle similar to a given triangle and draw tangents to a circle from an external point. Here are the geometrical instruments we will use to make the required constructions. You must be familiar with all of them. Let us begin. We'll start with the construction that divides a given line segment in a specific ratio. The given line segment is AB, and we'll divide it in the ratio 1:3. There are two ways of doing this. Using the first method, as step 1, draw a segment AC of any convenient length, making an acute angle with the given line segment AB. Now, you have to mark a few points at an equal distance from each other on AC. The number of points depends on the ratio in which you have to divide the given line segment. If the ratio is x:y, the number of points is x plus y. Here, the given ratio is 1:3, so the number of points you will mark on AC is 1 plus 3, which is equal to 4. Now, open the compass to any small convenient length. As step 2, mark 4 points: x1, x2, x3, and x4 on AC, so that AX1 is equal to x1 x2 is equal to x2 x3 is equal to x3 x4. Make sure that the distance to which the compass is open is not disturbed as you mark the points. At step 3, draw a line to join the points x4 and B. As step 4, use a pair of set squares to draw a line parallel to x4B from the point x1 to intersect the given line segment AB at point P. Point P divides the line segment AB in the ratio 1:3. Now, let us verify this construction mathematically. In the triangle ABX4, we know x1P is parallel to x4B. Thus, using the basic proportionality theorem, the ratio AX1 upon x1 x4 is equal to the ratio AP upon PB. By construction, AX1 upon x1 x4 is equal to 1/3. Thus, AP upon PB is also equal to 1/3. In other words, the ratio AP is to PB is 1:3. Now, let us learn about the second method to divide a line segment in any given ratio. Using the second method, start by drawing a segment AC of a convenient length, making an acute angle with the given line segment AB. Let us make a mark at, say, the 30-degree point. Now, draw the line segment AC as shown. Now we have to draw a segment BD of any convenient length, making the same angle with AB as AC. Let us again make a mark at the 30-degree point. Now, draw the segment BD as shown. Next, mark a few points at an equal distance from each other on AC and BD. The number of points depends on the ratio in which you have to divide the given line segment. If the ratio is x is to y, mark x number points on AC and y number points on BD or vice versa. Here the given ratio is 1 is to 3. So let us mark 1 point on AC and 3 points on BD. Now open the compass to a small convenient length. As step 3, mark 1 point, x1 on AC, and 3 points, y1, y2, and y3 on BD, such that AX1 is equal to BY1 is equal to Y1 Y2 is equal to Y2 Y3. Make sure that the distance to which the compass is open is not disturbed as you mark the points. As step 4, draw a line to join the points x1 and y3 to intersect AB at point P. Point P divides the line segment AB in the ratio 1 is to 3. Now, let us verify this construction mathematically. Consider triangles APX1 and BPY3. In triangles APX1 and BPY3, angle PAX1 is equal to angle PBY3 by construction, since we made both the angles equal to 30 degrees. Further, angle APX1 is equal to angle BPY3, since they are vertically opposite angles of intersecting line segments AB and X1Y3. Since the other two corresponding angles are equal, angle AX1P is equal to angle BY3P. Thus, by the AAA similarity criterion, triangle APX1 is similar to triangle BPY3. Since triangles APX1 and BPY3 are similar, their sides will be in the same proportion. Thus, AP upon BP is equal to AX1 upon BY3. By construction, AX1 upon BY3 is equal to 1 by 3. Thus, AP upon PB is also equal to 1 by 3. In other words, the ratio AP is to PB is 1 is to 3. Now, let us learn how to draw a triangle similar to a given triangle according to a given scale factor. But, what is the scale factor? You will find a scale factor on most maps. A unit of length on this map represents 500 units of actual length. You can also say that this map is 500% smaller than the actual place it shows. A scale factor determines how large or small an object is in comparison with another object. Construct a triangle similar to the triangle ABC with its sides 2 by 3 of the corresponding sides of the triangle ABC. Will the required triangle be smaller or larger than the given triangle? Since the sides of the new triangle will be 2/3 of the sides of the triangle ABC, it will obviously be smaller than the given triangle. Now, let us start with our construction. As step 1, draw a segment of a convenient length making an acute angle with the side of the given triangle. Here, let us draw the segment AX making an acute angle with the side AB of the triangle ABC. Now, you have to mark a few points at an equal distance from each other on AX. The number of points depends on the given scale factor. If the scale factor is x by y the number of points is equal to the larger value amongst x and y. Here the given scale factor is 2 by 3. So the number of points you will mark on AX is 3, since between 2 and 3, 3 is greater. Now open the compass to a small convenient length. As step 2, mark 3 points x1, x2 and x3 on AX so that AX1 is equal to x1, x2 is equal to x2, x3. Make sure that the distance to which the compass is open is not disturbed as you mark the points. As step 3, draw a line to join the points x3 and B. Now, locate the smaller value in the given scale factor 2 by 3. It is 2. So as step 4, draw a line parallel to x3b from the point x2 to intersect AB at point P. Finally, as step 5, draw a line parallel to side BC at P to intersect side AC at Q. Triangle APQ is similar to the given triangle ABC, and its sides are 2 by 3 of the corresponding sides of the triangle ABC. Thus, APQ is the required triangle. Now, let us verify this construction mathematically. From the figure, we can see that AB is equal to AP plus PB. Dividing both sides with AP, we get an equation that we'll call equation 1. By construction, PB by AP is equal to 1 by 2. Putting this value in equation 1, we get AB by AP as 3 by 2 or AP by AB as 2 by 3. In triangles ABC and APQ, PQ is parallel to BC. Thus, triangle ABC is similar to triangle APQ using the AA similarity criterion. Since similar triangles have their corresponding sides in the same ratio, we see that our construction is verified mathematically. The triangle APQ is smaller than the given triangle ABC. Now, let us construct a triangle similar to and larger than triangle ABC. Construct a triangle similar to the triangle ABC with its sides 4 by 3 of the corresponding sides of the triangle ABC. As step 1, draw a segment of a convenient length making an acute angle with the side of the given triangle. Here, let us draw the segment AX making an acute angle with the side AB of the triangle ABC. Now, you will have to mark a few points at an equal distance from each other on AX. As before, the number of points is equal to the larger value amongst the given scale factor. Here the given scale factor is 4 by 3, so the number of points you will mark on AX is 4. Now, open the compass to a small convenient length. As step 2, mark 4 points x1, x2, x3 and x4 on AX so that AX1 is equal to x1, x2 is equal to x2, x3 is equal to x3, x4. Make sure that the distance to which the compass is open is not disturbed as you mark the points. Now, locate the smaller value in the given scale factor 4 by 3. It is 3. So as step 3, draw a line to join the third point x3 to B. As step 4, draw a line parallel to x3b from point x4. As step 5, extend the side AB of the triangle ABC to meet the line drawn from the point x4 at P. As step 6, draw a line parallel to side BC at P as shown. Finally, as step 7, extend the side AC of the triangle ABC to meet the line drawn from point P at point Q. triangle APQ is similar to the given triangle ABC and its sides are 4 by 3 of the corresponding sides of the triangle ABC. Thus, APQ is the required triangle. Now, let us verify this construction mathematically. In triangles ABC and APQ, PQ is parallel to BC. Thus, triangle ABC is similar to triangle APQ. Since triangles ABC and APQ are similar, their corresponding sides will be in the same ratio. Since BX4 is parallel to BX3, triangles AX4P and AX3B are similar. Thus, AP by AB is equal to AX4 by AX3. By construction, AX4 by AX3 is equal to 4 by 3. Thus, AP by AB is equal to 4 by 3. Hence, all sides of the triangle APQ are 4/3 of the corresponding sides of the triangle ABC. Now, let us learn how to draw tangents to a circle from an external point. Draw tangents to the circle with a center O from point P lying outside the circle. How many tangents can you draw to the circle from point P? Only 2. You can draw only 2 tangents to a circle from an external point. Let us start with the construction. As step 1, join the external point P with the center of the circle O. As step 2, we have to draw the perpendicular bisector of line segment OP. To draw the perpendicular bisector of OP, open the compass a little more than half of OP. Place the compass at O and mark 2 arcs above and below OP as shown. Next, place the compass at P and mark the 2 arcs above and below OP to intersect the arcs marked in the last step. Join the intersection points to get the perpendicular bisector of OP that intersects OP at M. Thus, M is the midpoint of OP. As step 3, draw a circle with its center at M and radius equal to MO. This circle intersects the given circle at 2 points A and B. Finally, as step 4, join AP and BP. These are the 2 required tangents. Now, let us verify our construction mathematically. To verify this construction, let us draw a line to join the points O and A. Now, consider angle PAO. It is an angle in the semicircle and therefore equal to 90 degrees. So we can say that PA is perpendicular to the radius OA of the circle. By definition, PA is therefore a tangent to the given circle. Similarly, PB is also a tangent to the given circle. You've reached the end of this section. In this section, you learn to divide a given line segment into a given ratio, construct a triangle similar to a given triangle as per the given scale factor, construct a pair of tangents from a point external to a circle. Hope you enjoyed the learning experience.